Till now, we have studied about the states of matter. Now we will start about the categorization of matter based on their purity. That is, matter can be of two types, pure or mixture. For pure type of matter, there would be only one type of compound in that. But for mixture, there can be more than one type of compounds in the same system. So let's start. So on the basis of purity, we can talk about in bulk level. Okay. Matter can be classified as pure and mixture. So pure has fixed composition. Because it is made up of only one type of particles. But mixtures are made up of more than one type of particles. And their ratio is not fixed. No fixed ratio. Okay. Now pure can be of two types, elements and compounds. Elements are generally made up of atoms. Okay. For example, let's say carbon, argon, gold, silver, all these are elements. Okay. But the compounds are made up of molecules. That is, one molecule is made up of several different types of atoms. So let's say water or carbon dioxide, sodium chloride, everything are compounds. And mixtures can be differentiated as homogeneous and heterogeneous. Okay. Homogeneous mixture is generally referred to a mixture in which all the different types of particles are in the same state. Let's say if we are mixing water and milk, that's a homogeneous mixture. And heterogeneous mixture is, for example, we have water and sand. So that will be called as a heterogeneous mixture. So methods of separation. Mixture can be generally separated by hand picking, filtration, decantation, distillation, crystallization, etc. Okay. So these are the methods for separating a mixture. But constituents of a pure compound cannot be separated by these methods. Okay. constituents of pure compounds cannot be separated by simple methods or by physical methods. Okay. So, for the separation of different constituents of compound, we need to perform chemical reactions. Now, we were talking about compounds, right? So, elements are made up of single atoms and compounds are made up of molecules. So, we know that, for example, we have two hydrogen atoms. They combine to form a hydrogen molecule. Okay. Let's say one hydrogen molecule is formed. Again, we have two hydrogen atoms and one oxygen atom. They will combine to form one water molecule. So, in this case, we had taken one hydrogen and one hydrogen to form H2. Okay. For example, if we say carbon monoxide, CO, then we have one carbon plus one oxygen. But for CO2, we have one carbon plus two oxygen. Similarly, for water molecule, we have two hydrogen plus one oxygen. So, they are in different ratios. So, the mixing of different types of atoms, or we can say the bonding of different types of atoms, are based on various factors. They depend on their concentration, they depend on their ratios. So, we will study about them one by one. So, if we talk about the measurement of matter, we had already said that the matter needs to be described on the basis of certain entities, that is mass, volume, length, density, etc. So, these are the properties of matter. There are different types of properties which can be broadly classified as physical properties and chemical properties. Among the physical properties, we can talk about mass, volume, density, and like at room temperature, what will be the state of matter, or at any specific temperature, what will be the state of matter. These are the physical properties. But when we talk about chemical properties, oxidation, reduction, combustion, polymerization, different types of chemical reactions, they come under the chemical properties. So, properties of matter can be classified into physical and chemical. Okay. Among the physical properties, the major factor is that physical properties can be measured without changing its identity. Okay. When we measure the physical properties or we observe the physical properties, the main composition or identity of the matter remains unchanged. For example, color, density, melting point, boiling point, solubility, etc. But the chemical properties cannot be measured without changing the identity. Okay. Measurement or observation requires chemical change. That is, we can observe the chemical properties by performing chemical reactions. For example, acidity, basicity, we can sum this up as pH, combustion, reactivity, etc. Okay. These are the chemical properties. So, first let's talk about the physical properties. So, among the physical properties, we have entities like mass, length, volume, etc. So, when we are talking about, let's say, the mass of a substance, okay. So, let's say we have a box, we have to measure its mass and its volume and its surface area, okay. So, to measure the surface area or volume or mass of the box, we need to know about units. That is, we measure mass in terms of grams or kgs. We measure the length in terms of meter or centimeter, etc. Right? So, we need specific entities to describe a quantity. If we say that the mass of this box is 5 meters, that makes no sense, right? We have to say that mass of the box is 5 kg. So, for different types of entities, different units are assigned. But previously, different countries or different regions had their own units of measurement. Like even in India, if we travel to different parts, we can see that still people use different units for measuring. But when researchers started to develop, it was very difficult to communicate between different countries with different types of measuring units. So, all the countries decided to have a standard system of measurement. So, there is something that we called international system of units. Okay. In short form, we call it as SI. So, SI system was established at 11th General Conference on weights and measures. Okay. So there was this general conference on weights and measures, and there the SI system was established. So SI system has basic 7 types of entities. Okay. So SI system has 7 base units for 7 fundamental quantities. Fundamental scientific quantities. Okay. All the other quantities are measured as a derivation of these 7 base units. All the other quantities are derived from these fundamental units. Okay. So let's see what are these base units. Physical quantity, symbol, and SI unit. Okay. So the first one is length. Length is symbolized by the small l, and its SI unit is meter, which is denoted as m. Okay. The next quantity is mass. Mass is denoted by small m, and the SI unit is kilogram or kg. Next is time. Time is written as small t. The SI unit of time is second, which is written by small s. See, sometimes we write as SEC, sometimes we write as S, but this is not the correct form to write second, okay? This is the correct form. The next quantity is electric current. Electric current is symbolized by capital I, and its SI unit is ampere, capital A. Okay. Now, one thing is to be denoted that ampere was the name of a scientist. Like we have many other units which are derived from the names of scientists like Newton, Pascal, etc. Right? So, whenever we are writing the name of the person, we will use the capital letter. For example, when we are writing Newton, about Isaac Newton, okay? So, we will write with capital N. But when we are writing it as the unit of force, Newton, that we will write with small n, okay? That is when we were writing the full word. Like here, when we are writing ampere as a unit of electric current, we will write it with small a, okay? This is the unit of electric current. But when we are talking about the person ampere, we will write it with capital A, okay? So, the next quantity is thermodynamic temperature. Which is denoted by capital T. Its SI unit is Kelvin, written as capital K. The next one is amount of substance. It is denoted by small n, and the SI unit is mole, and we write mole as MOL. And the last unit is luminous intensity. We denote it as IV, and the SI unit is candela, CD. Okay. So 1, 2, 3, 4, 5, 6 and 7. These are the 7 fundamental scientific quantities for which we have the 7 basic SI units. So we will study about the derivation of other quantities from these SI units, and we will discuss about these quantities one by one in the next lecture. Thank you.